Okay, simplifying square roots, section 9-2. Radical form, this is just your definition. It's an expression that uses the square root symbol. Product of properties, square roots. Okay, so it says the square root of a times b is the same as the square root of a times the square root of b. Okay, so why would we want to do that? Well, maybe on something like this, if we had the square root of 20, we could break it into the square root of 4 times the square root of 5, because the square root of 4, whoops, bad color, is 2. So the square root of 20 is the same as 2 times the square root of 5. Now we'll get into this a little bit more, but this is kind of where we're going today. I don't want the decimal answers, okay? We're going to look at some perfect squares and things like that, but this is the kind of answer we're going to be looking for today. So the product property square root would just be the opposite of that the square root of a times the square root of b would be the same as the square root of a times b. Okay? So if you had the square root of 4 times the square root of 5, it's the square root of 20. Square root of 2 times the square root of 14 is the square root of 28. It's just another way to rewrite that property. The product properties of square roots says the square root of a times the square root of a is just a. Okay, because the square root of a times the square root of a would actually be the square root of a squared. Square root of a squared is just a. So short way, if you have the square root of 5 times the square root of 5, it's just 5. Square root of 11 times the square root of 11, it's just 11. Okay, so like I said, what we're going to have it look like. What you do, if you remember factor trees, maybe this kind of looks like that, but basically we're going to break down 50. So we're going to say, well, what times what gets me 50? Well, I could say 5 times 10. I could say 2 times 25. Okay, so let's just go 5 times 10. Look for your prime numbers. Okay, 5 is prime, so I'm done on this side. 10 is not prime, meaning I can break it down a little further. I get 2 and 5. Okay, these are all prime numbers. 5 times 5 is 25 times 2 is 50, or 5 times 2 is 10 times 5 is 50. It all gets me 50 no matter what order I multiply it in. Now what I do is I look for the pairs. I have a pair of 5s. Okay, the square root of 5 times the square root of 5 is just 5. So it's not under the square root symbol anymore. The 2 doesn't have a pair, so it's going to stay underneath. And that's your answer. Okay, square root of 98, let's try it with another one. That would be 2 times 49. 2 is prime, 49 is not, so I'm going to keep going. All right, I got a pair of 7s. Square root of 7 times square root of 7 is just 7. Again, I don't have a partner for my 2, so it's just going to stay underneath. Okay, prime factorization. All right, so that's what we were just doing on that last one, where we say, okay, I look for all the prime numbers. Like 2 times 10 is 20, 2 times 5 gets me that. So I have a pairs, so it's 2 times the square root of 5. That's kind of hard to see. Hang on. I'll change that to white. Okay, using perfect squares is a little different method for doing this. What you do is you look for the perfect squares that go into our number. For example, 4 is a perfect square. Okay, so it's the square root of 4 times the square root of 5 is basically what we're saying. Well, the square root of 4 is just 2. Square root of 5 does not come to a nice number. Okay, so same answer. It's just a matter of if you'd rather do where we break it down into prime numbers, or if you're good at your perfect squares, you know, this might be a shorter method for you. Okay, so same problem. Again, sorry, I'll change that to white. All right, so prime factorization. Let's try a perfect square this time. Okay, so I think of what goes into 45, that's a perfect square. Well, 9 does. Square root of 9 is 3, and square root of 5 we just leave. Okay? Prime factorization, I'd say, well, let's see. 15 times 3 gets me 45, or 3 times 5 gets me 45. I have a pair of 3s. Square root of 3 times square root of 3 is just 3. And then I have the square root of 5. I could have went with 9 and 5 here as well, but I thought I'd use a different pair just so you can kind of see what it would look like. Either way, we get the same answer. Okay, so if you're going to do the perfect square method, you need to have a list of the perfect squares. Okay, for example, 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square. 16, 25, 36, 49, 64, 81, 100. All of those are perfect squares. So if you know one of these numbers goes into our problem, you could use the perfect square method and then it'll get you there in shorter steps. Or, again, we could list the prime numbers, because if you do the prime factorization method, you need to stop when you get to any of these numbers. Okay, that should probably be the biggest one we would have. So if you get any of these numbers when you're doing the factor tree and you get your prime numbers, stop when you get to the prime numbers, just circle them. If it's not one of these numbers, that means we can break it down further and we can keep going. All right, so let's use that on this one. Okay, so 450 would be 45 times 10. 45 is not prime, so I'm going to keep going. I'm choosing the prime factorization method, obviously. I'll switch on the next one if I can. So 5 times 9, that one's prime. Keep going. These are both prime, and those are both prime. So I look for my pairs, all right? I got a pair of 5s, and I have a pair of 3s. So square root of 3 times square root of 3 is just 3. Square root of 5 times square root of 5 is just 5. And 5 times 3 gets me 15. Okay? And then I have my 2 underneath. That's my answer. Or, here, let's do it this way. I'll show you the prime factorization on this one. Okay? So like 225 times 2. Well, that one's, oh, I don't want to do the prime, sorry. So this would be the square root of 225 times the square root of 2. Square root of 225 is 15. And then we just bring that down. Okay, so if you had your perfect squares memorized, you'd know the square root of 225 is 15, and you could go with that. All right, 72, let's try the perfect square method. All right, that's going to go square root of 9 times the square root of 8. Okay, square root of 9 is 3. Well, this actually can break down a little farther. This is square root of 4 times the square root of 2. Square root of 4 is 2. Square root of 2 we can't do. 3 times 2 is 6. Square root of 2 would be our answer, if you choose the perfect square method. Okay? Let's try the prime factorization on this one. We could just say 9 and 8. Neither one's prime, so I'm going to keep going till I get prime numbers. Okay, so I have a pair of 3s, I have a pair of 2s. 3 times 2 is 6. And I still have a 2 left underneath. Okay, I'm going to say 90% of you are going to pick this method, so from now on I'm just going to use this method. If you really like the other method, go for it. Okay, 108, well that's even, so we know 2 goes into it. Let's see, 2 would be 54. That one's prime. Keep going. This would be 9 and 6. Keep going, because neither one is prime. 3 times 3 is 9, 2 times 3 is 6. All right, I got a pair of 3s and I got a pair of 2s. So 3 times 2 is 6. And then I still have that 3 left underneath. All right, oh, we already did 20. Okay, this one's a little different in that there's a number out front. Okay, just ignore it for now. Break down your 20. All right, I get 2. Well, there's already a 5 out there, so I'm going to take 2 times the number that's out there, which is now 10, and then I still have my 5 left underneath. Okay? Difference between that one and this one. This one has the 5 under the radical. This one didn't. Okay, so what this means is I can go ahead and multiply those together. Square root of 5 times the square root of 20. 5 times 20 is 100. So I could break down 100, or if you already know the square root of 100 is 10, you could just stop right here. Or you could just keep going, so 10 and 10. 2 and 5, 2 and 5. So I have a pair of 2s, pair of 5s, 2 times 5 gets me 10. Okay, so a little different answer. Just look at what you're given and take it from there. All right, this one I would multiply together. So you've got your 2 and your 6 is 12, and your 5 and your 10 is 50. Now ignore the 12 for now. Break down the 50. So 5 and 10, this one's prime. 2 and 5, those are both prime. So I'm going to bring out the 5, but there's already a 12 there. So I'm going to take 5 times 12, which is 60, and then I still have my 2 left underneath. Okay? 4 times 5 is 20, And you know what? You don't have to multiply the 12 times 24. Let's save ourselves a step. You know it's going to be 12 and 24, and then you're going to have to break it down anyway. So let's just take it from there. The 12 would be 6 and 2. This would be 3 and 2. 24 would be 6 and 4. 2 and 3. 2 and 2. Let's look for our pairs. I got a pair of 2s. I got a pair of 2s. And I got a pair of 3s. Okay? So 3 times 2 is 6. Times 2 is 12. Times the 20 that's already out there, excuse me, is 240. And then we still have a 2 left underneath. Okay? So again, I had 3 times 2 is 6. 6 times 2 is 12. 12 times 20 is going to give me 240. But I still had this guy left, so he's got to stay underneath the radical. Okay? That's where we'll stop for today.